All right, hello, math fans. Right now, we're going to work on special types or special cases of systems. So let's see what we actually mean by that. Let's start out with a nice problem here. Okay, so we have 2x minus 3y is equal to 5, and 6x minus 9y is equal to 15. So this is obviously we're going to use elimination here, and we're going to multiply. If I want to get rid of the x, I can multiply the top by negative 3. So I put this below it. I get negative 6x plus 9y is equal to negative 15. All right, and if you notice what's going on here now is we definitely tried to eliminate our x, but our y is also going to be eliminated. Okay, because these cross out and it's 0, this cross out. So actually everything cancels out. You have a 0 on the left hand side. And then if you notice, this guy also cancels out, right? You cancel out, you get a 0. So 0 equals 0. So this is the deal. This is true. Now, before we answer what true means, what type of question this is, I want to actually look at both of these problems. I have 2x, this is my original problem, equals 5. And if I solve for y, because let's say I want to graph this because we've done this before. I subtract 2x from both sides. So we get negative 3y is equal to negative 2x plus 5. Divide everything by negative 3. Y equals positive 2/3 x minus 5/3. Okay, so that's one equation. And if I do the second equation, 6x minus 9y is equal to 15, and I do the same thing. Subtract 6x, so negative 9y is equal to negative 6x plus 15. Divide by negative 9. So y equals, if I reduce that, I get positive 2/3 x. And I reduce that, 3 goes in each of those, that goes into 5 times and 3 times, so minus 5/3. So here's my second equation. And if you notice, they're the same equation. Okay, so what does that mean? If I would actually graph these, and if it's the same equation, so let's kind of roughly graph it here. If I graph it, it would look something like this, and then the other one would look something like that. So it's the same line. So if it's the same line as we remember when we did graphing, it's going to be the answer for this one is going to be infinite many or infinite solutions. That's the infinity sign. Okay, or you can write infinite solutions. Now, a bad answer, as we know from the past, is all real numbers. This is actually not acceptable because all real numbers mean, if I would kind of make a quick just graph right here in the middle of the page, all real numbers mean, and here's my line, all real numbers means here and here and here and here and here and here, all these values. That's what that's what all real numbers means. It means every single point on that graph. And that actually is not true. It's on a number line, it's every point because it's just one number line, it's one line. With an XY graph, it's not all real numbers. It's an infinite number because it is a line and it's going on for infinity, but it's not every answer. It is just an infinite number. So this is what you need to put for an answer. Now, if you go back to our original problem, it's 0 equals 0. If that's true, then it's infinite solutions. Okay? So if that's true, it's infinite solutions. So let's go back and let's do another case here. (3y) is equal to 6x minus 9, and 2y is equal to 4x plus 8. Now remember, before you can do an elimination problem, you have to make sure everything lines up. It's very important. Okay, if it doesn't line up, you can't do the problem. Okay, so let's eliminate, we can eliminate either the x or the y, and it does line up, right? The x's are in one column and the y, even though they're not both on one side. That's okay. All right. So what I can do is let's get rid of the y. Sounds good to me. Going to multiply that by -2, and this one by +3. So that's going to give me -6y is equal to -12x plus 18. And 6y for the second equation, 6y equals 12x plus 24. And you notice that's a 0, that cancels out. And the only time you write 0 if there's no other placeholder there. If there's a placeholder like this guy here, I don't need to write 0 because it cancels out, and you actually can add these together. So 18 plus 24 is 42. So this is the deal. Does 0 equal 42? Well, no, of course not. It's false. So what do you think the answer to this one is? Well, let's take a look at this one again too. If I redo the first, or rewrite the first equation, solve for y, I'm going to divide everything by 3. So I get y is equal to 2x minus 3. And if I do the second equation, divide everything by 2, I get y is equal to 2x plus 4. And what did I tell you in the beginning, back in the day? It's got the same slope. If it's the same slope, what kind of lines are they? They're parallel lines. Okay, so parallel, if I would graph both of these lines, I'd have 1, 2, 3, 4. So it's roughly going to look like this. And then -1, 2, 3, it's roughly going to look like that. So these lines are parallel. The solution to the lines are wherever they cross. Where do these lines cross? They don't cross. So if they don't cross, if they're parallel, that means it would be no solution. So if I go back to obviously this is with graphing, but if I go back to my original problem where I'm doing elimination, this is the deal. If 0, which does not equal 42, it's false, so that answer is no solution. So those are your two cases. Okay, so this is the deal though. In order to have one of these special cases, the variables, so I'm going to write this out here, the variables must cancel. That is super important. The variables must cancel. If the variables don't cancel, then you have just one solution, a normal solution like we've learned in the past. So in other words, everything cancels and you get like 0 equals 5. Well, no, it doesn't. No solution. 5 equals 5. Yes, that's true. It is equal, so that means it's infinite solutions. Okay, -105 equals -105. True, infinite solutions. 0 equals 0. True, infinite solutions. It's very easy. Now I want you to be careful, because if you have a problem where all of a sudden you got 5x equals 0, I don't want you to say no solution. If you still have a variable here, you have to divide by 5, and you get x equals 0. So that would be one of your answers, x equals 0. Okay, let's try one more or a couple more problems here. I get y is equal to x plus 2, and x minus y equals 3. Now, as I told you before, if it's already solved, you don't want to use elimination method. You can by moving the x over, but why not just use substitution? It makes more sense. So I'm going to plug that into there, and I get x minus parenthesis, what's y? It's x plus 2 equals 3. So again, this is my equation with the y being substituted in as x plus 2. Okay, so if we distribute that negative, so we get -x minus 2 equals 3. So this is what's going on, is this guy's actually canceling. X minus x is 0, so it's 0 and then it's minus 2. So it's really -2 equals 3. It's not true, so it's no solution. Very simple. Okay? If the variable cancels out, it's no solution. If the variable doesn't, or cancels out, I should say if the variable cancels out and it's equal, it's infinite many solutions. If it's not equal, it's no solution. All right, let's try one more. 5x minus y equals 3, and negative 10x plus 2y equals negative 6. So I'm going to multiply this one by 2. So you get 10x minus 2y equals 6. That cancels. 0 equals 0. It's true. Infinite solutions. Okay, so you got to look for that. The variable cancels out, then it's either no solution or infinite number of solutions. One of the two. All right, so that's it, math fans. That was pretty fast, and I hope you learned something. Goodbye.